We've said that a diode has zero resistance facing in one direction and infinite resistance facing the other. Let's do an experiment to see if this is really true and to look in more detail when that change happens. It's a similar setup to one we've used before. To stop the current through the diode getting too high, we're going to put a resistor in series with it. This means that no matter how low the diode's resistance gets, the current can't get any bigger than the current that would flow if the resistor was by itself in the circuit. We'll break the circuit and insert an ammeter to measure the current. And we'll use a voltmeter to measure the PD across the diode. Then we'll use the power supply to change the PD across the diode and measure the current through it. First, we'll measure the current with a diode pointing in the right direction. If the voltage is very small, the current stays zero, even though it's trying to go through the diode in the right direction. As we gradually increase the voltage from about 0.5 volts to 1 volt, the current starts rising rapidly until we max out the power supply. Now we need to see what happens when we try to make the current go the wrong way through the diode. To do this, we'll just swap the leads of the power supply. We'll say these are negative voltages. With a low negative voltage, the current is zero. As we increase the voltage, the current stays zero. We can plot the current through the diode versus the PD across it. It's not a straight line through the origin, so a diode doesn't obey Ohm's law. Above about 0.7 volts, the current rises rapidly for each small increase in voltage. If we use R equals V over I to calculate the resistance of the diode, we can see that it drops rapidly after 0.7 volts and is as low as it's going to get once we near 1 volt. The voltage at which the diode starts to become good at conducting is called the threshold voltage.